You're listening to Data Science Leaders, the premier podcast for executives tackling the world's most important challenges using the power of machine learning. Let's dive in. Hello and welcome. Today we are speaking with a founding figure in today's AI community, Eric Siegel. Dr. Siegel founded the first major conference focused on the business uses of artificial intelligence, and that is ML Week. It was originally Predictive Analytics World, started all the way back in 2009 before most of us were even talking about data science. He's written the best-selling business book on machine learning, Predictive Analytics. First came out in 2013 and has been updated regularly in many editions. And he has just written a new book called The AI Playbook, Mastering the Rare Art of Machine Learning Deployment. He is also the creator of by far the best music video on machine learning that's out there on the internet. It might also be the only music video on machine learning that's out on the internet. Eric, welcome to the podcast.
Thank you, Shell. It's great to be here. Thanks for the opportunity. The video is Predict This. So it's 3.5 minutes long, educational, predictthis.org.
It is phenomenal.
Absolutely.
Eric, one of the things that I really liked about your first book was the degree to which it filled this missing gap, which arguably still exists today, in terms of content that addresses the business use cases and the business challenges of machine learning. So not just talking about it from the technology point of view, and also not just talking about it exclusively from the business point of view as if there were no technology components about it, but really being in that intersection. It was like the first compendium of use cases that I saw that was really out there, and of case studies about how folks were successful in driving impact. So that begs the question, why the need for the new book?
Well, both books are meant to be accessible to all readers, and I love bridging that gap between biz and tech. The first book really is about how machine learning works, and the new book is how to capitalize on it. So it's the business framework, the business process that's often omitted, and what's needed to bring together those two sides deeply in a deep collaboration so that you can run a machine learning project successfully to deployment.
Yes, vastly easier said than done. I would love to get your thoughts on that gap. Why has it been so difficult to get hold of that middle ground, to go in and be able to bridge that? We all talk about the need for analytics translators, and we've been talking about it for years. Why is it so difficult?
Well, it can happen, and there's plenty of successes, but most new machine learning projects fail to achieve deployment and therefore fail to capture value entirely. There's a bit more follow through as far as the ramp up on the business side, having a semi-technical understanding of what's predicted, how well, and what's done about it in a concrete way, all stakeholders involved in the project. And then with that knowledge in place, following a deeply collaborative practice that I formalized into the 6 steps of BizML, that plans from the get-go exactly what deployment will entail. So, let's be a little bit more concrete. Most of these projects are failing. We've gotten really good at sweeping the failures under the rug, in part because AI is so hyped up and hot right now. It kind of helps sweep failures. You're using the best technology, but are you acting on it? You're creating or generating value by making a predictive model, but are you capturing the value by actually getting it deployed so that operations are improved? So, for example, in research that I conducted with Rexer Analytics in their data science survey, only 22% of data scientists say that new capabilities initiatives with machine learning usually deploy. So you can find a bunch of information online we have published about the results. But I think more to the point, let's focus on the solution, which is keeping your eye on the ball, which is the deployment. It's a business project first that uses machine learning rather than being a technology project where you can kind of separate the number crunching and say, hey, data scientists, go off and crunch some numbers. We'll figure out deployment later. Not at all. There's a very stringent practice what I want to evangelize is BizML. I think it's a nice, I think I've coined a nice buzzword for it, but the main point is to put a brand on it so that there's an understanding and a general knowledge that we need a specialized business practice, framework, paradigm, playbook. It's the titular playbook of my new book, the AI Playbook, in order to run machine learning projects so that they're successful in this way. That's something that many or most business professionals are not aware of the need for that customized or specialized practice, let alone any particular formalization thereof. So if we get this out there, it becomes a widespread understanding. There's this common understanding that we need to follow it. And secondarily, equally important, that the stakeholders need to ramp up. And that's just those list of three. I'll say it again. What's predicted? Is this transaction fraudulent? Will this customer buy if I contact them, et cetera? How well? What are the right metrics? And what's done about it? How do you act on what's the integration, implementation, deployment going to entail in the change to operations driven by the outputted predictions that machine learning models generate? How is that integrated? What's the deployment going to involve? It's a change to business. It requires change management, foresight, planning, both technically and organizationally.
Absolutely. There were a lot of things that you covered there. I'd love to go in and unpack them and go into them in a little bit more detail. The first struck me as around that need for education. That this isn't. We've all been tackling this from the point of view that, well, our data scientists need to become better communicators. Our analytics folks need to become better communicators. And there's an element of that where, yes, obviously we need to do that, but we also need to educate the business stakeholders, the other parts of the organization, whether they be the folks in marketing, whether they be the folks on the IT side of things, to go in to understand that this isn't just a technology problem. This isn't something that you can buy on its own. It is something that they are going to have to be involved with and iterate on and upskill themselves on what's necessary in order to become an effective participant and also a driver of adoption for this. Is that true?
Whether you read the book or not, there needs to be an agreed set of basic steps. The 6 steps themselves, if you're a data scientist, once you think it through, they kind of write themselves. But the bigger theme here is to involve business professionals, stakeholders such as those who are in charge, let's say a line of business manager in charge of the operations meant to be improved by machine learning. But whatever it is, the business professionals involved in or touched by the project need to get involved in the details. And it's not an intimidating amount of analytical or technical details. It's what I said, what's predicted, how well, and what's done about it. In fact, establishing those 3 elements in a certain amount of detail from a knowledgeable standpoint, collaboratively with data scientists, are the first 3 steps of the 6-step BizML process, as I formalize it in the book. Not quite in that order, but those first 3 steps are essentially pre-production steps. And it's like driver's ed, not auto mechanics school. Everyone's got to learn driver's ed. There's expertise for driving a car. You don't have to pop the hood. You don't need to know where the spark plug is, but you need to know the rules of the road, momentum, friction, how the steering wheel works, expectations of other drivers and theirs of your driving, etc. Same thing with driving a machine learning project successfully to deployment. There is a meaningful amount of knowledge. And I'll just plug the book by saying the purpose of the book, while stepping through those 6 steps separated into the main 6 chapters of the book, is along the way to ramp up business readers in that amount of semi-technical understanding of how machine learning works, down to what's predicted, how well, and what's done about it.
Yeah, so arguably it's a different kind of education. A lot of folks on the business side are intimidated because they're thinking, oh, okay, I need to go take a data science course. I need to go in and understand or prove the efficiency of an estimator. I need to go in and get my hands dirty with Python code and R. And that would be great. That'd be wonderful. There's nothing wrong with doing that.
Right.
But that's actually different from the kind of knowledge that they really need, which is one of understanding the problems, understanding that what we should be going after, understanding the challenges that you face working with data, understanding the process and the project.
Yeah. And in fact, it's different, which means it's an additional amount of conceptual knowledge that even the technical data scientists need. I mean, I've been in machine learning for more than 30 years, and I'm like most data scientists. I was super excited about the core technology. It's like the world's more excited about the rocket science than the launch of the rocket. But that's what it's like to be a nerd, right? So we have, and it's very concrete, tangible. Hey, this technology learns from data. It makes a model. It predicts this well. Great. Isn't that awesome? But if you're going to achieve business value with it, there's more learning, not only that's needed on the business side, but also to to enable that collaboration. Data scientists need to get into it as well. So, for example, among those three, what's predicted, how well, what's done about it? The second is the metrics. How well? How do you measure the performance in a meaningful, tacitly, relevant way for the project? And accuracy is usually the wrong metric and often misleading. Lift is fine. Precision recall, AUC has the same problem as accuracy, doesn't differentiate between false positives and false negatives. So these are all technical metrics, and these are the ones that people they're dealing with. They only tell you the relative performance of the model compared to, say, a baseline like random guessing. And then you get excited as a data scientist. This thing's clearly predicting much better than guessing. That's potentially very valuable. Valuable, though, would be a business metric, something super straightforward like profit, number of customers saved, number of dollars saved. We need to be regularly, systematically translating it also into those types of KPIs, those business metrics. And how do you do that? Which are the pertinent ones? This is where both sides need to ramp up on this kind of data literacy and move toward that middle of this, what's still an enormous gap in general, so that they can come together and collaborate deeply.
You're reminding me of any number of conversations that I've had with practitioners where they're practically like therapy sessions, where it's we went after the wrong problem, or we went after the right problem, but we didn't have the data, or we managed to get the data, but we couldn't build a model that was actually predictive. We were able to do that, but we couldn't get it deployed. Oh, no, we got it deployed. We got it out there. We got it in the hands of end users, but they didn't have a way to consume it. Oh, no, we did that too. We even had an application at the end of it. It was all perfect, and then they didn't adopt it. And so unless you're going in and really making the case, persuading them, give them a reason for it, for why they need to.
And right. So we one of the main examples in the book is UPS predicting tomorrow's deliveries in order to optimize how how packages are allocated to the delivery trucks and then loaded over, and all the planning and loading has to happen overnight for the truck departure in the morning. And the people on the loading dock even though there was a more optimal way, they weren't necessarily following the prescriptions. You need to get that agreement, that buy-in. It's like a full stack organizational buy-in from the executives down to people who are actually implementing the operations. But as far as it being a therapy session, I prefer group therapy. So chapter 0, which outlines the 6-step practice before chapters 1 through 6, opens with my therapy session where I was doing dating defection. So predict which paying customers are going to cancel for online dating site, a very popular one that I talk about in the book. And so I'm like, I convinced my client and they're like, sure, make a churn model. And then I made the nice PowerPoint. Here's how much you stand to gain by deploying this with a new targeted marketing campaign. And they're like, oh, you want us to do something? It's not just number crunching. You want us to use it, right? And they're like, okay, so I got paid, right? But it takes a while to learn the lesson about the proactive planning. If you're the data scientist, but you're the one pitching the project, it's your responsibility to be pitching what the project actually would mean, which is operational change, operations improvement, not just number crunching. And that's the missing thing. And it's taking the industry a long time to learn that, but it's going to catch up with us, right? The executives are getting wise. IBM recently came out with industry research showing that the average returns of AI projects are essentially not there. The average returns are lower than the cost of capital. There's more and more of these types of reports coming out. The stuff's going to hit the fan. It's not like we can sit around and this is not sustainable. So something has to change, and it's an organizational issue. It's an organizational practice that's proactive more than new technology.
Indeed. So going back to the framework, BizML, a lot of folks will immediately think of CRISP-DM, that cross-industry standard process for data mining from Yore. And obviously there are problems with that framework, amongst not least of which is the fact that it's a dead framework. No one owns it, and it hasn't really been further developed or refined for decades. But could you speak anything about the similarities and differences between BizML and CRISP-DM or other frameworks you've come across?
Yeah, I mean, a lot of people will think of CRISP-DM, but those people have white hair like me. the only people who've heard of it are old data scientists. Of course, that's probably a sweeping generalization, but it didn't catch on. It failed. It's not known to business. This is a business practice. Business stakeholders need to know it. Business stakeholders, again, aren't even aware of the need for a specialized or customized practice process framework for running machine learning projects successfully to deployment, let alone the name of any one particular. But yes, years gone yore, you said from times gone yore, more than 30 or about 30 years ago is when CRISP-DM came out, hasn't been updated. The thing is it's right there in the name. It's called data mining. The other thing though is that it was not specialized for machine learning projects. So as I've mentioned, what's predicted, how well, what's done about it. The most actionable thing you get from data is prediction. That's why machine learning is the most important general purpose technology. I want to create a buzzword that evangelizes the need and solution for this type of practice, and one that's specialized for machine learning in particular, because that's where the opportunity is. Mostly what we're talking about today is sort of more predictive machine learning. That's older than generative, but it's not old school. It's hotter than most of the gains, earnings, and money is still much more in that area than it is in generative AI. And they're really apples and oranges. It's not a zero-sum game. But predictive is where there's still tremendous opportunities as yet untapped. We're not capturing the value nearly as often as we potentially could be.
Well, it strikes me that as an industry, we've moved from what was primarily an insights generation exercise. Mostly this was, we're going to analyze data, we're going to figure out some pattern, and then we're going to take those insights and go in and change machinery, change people, or reconfigure in order to act on it. Versus now, when we're talking about AI machine learning, largely, yes, we need to understand the data, we need to understand what's going on, but the end goal isn't a visualization or a spreadsheet or something like that. It's a model that's plugging into an application that is going in and, as you say, are driving predictions or actions on an ongoing everyday basis, and that's where we get impact at scale. So it sounds like, whereas CRISP-DM very heavily oriented towards that insights generation process, we need another framework that really is aligned around model deployment and an application at the end of the day.
Yeah, I mean, that's where the money is, right? That's the ka-ching value, is if you're actually optimized. I mean, that's what machine learning stands to do. That's its potential, is to improve pretty much all our large scale operations, all the main things we do as organizations across sectors. It's about triage, right? It's about allocation of resources for targeting marketing, fraud investigations, credit risk, ad targeting, which satellite should be inspected for a battery running out, which locations should I drill for oil. You've got limited resources and you're allocating them better. And of course, in healthcare applications, then it's literally triage. Who should I test before I discharge him from the hospital as a high risk of being readmitted? Which door should I knock on as a nurse practitioner to ensure that the patient is complying with their prescribed behaviors or medication? There's limited resources. We need to prioritize, and that's what probabilities are for, right? Probabilities, we don't have magic crystal ball. We can't make definitive predictions, but the value is in putting a number on the odds of this, whatever outcome or behavior would be valuable to predict to improve operation. And then the real value is in actually acting on that systematically across many, many decisions, because that's what operations are. There are many decisions. Business is a numbers game. We're tipping the odds slightly in our favor by playing them that much better with probabilities. This is what it means to use science to run business more effectively.
Yes, we say prediction, but what we really mean is prediction in support of action. It's that they're the same class of problems. I noticed that you avoided the temptation to call the framework BizAI, even though that might have led to more adoption and more interest by some of the business stakeholders. And generally, in the book, you're trying to stay away from AI washing and hype as much as you can. Is there a reason why you avoided that term? Are you looking to drive more specificity around what it is that we're doing, or what was the driver?
When I was a kid, they always said to me, say what you mean and mean what you say. what does AI mean? Okay, now in some contexts, it's very well defined and has a particular meaning, but I have ventured to say that in most contexts, it generally conveys misinformation in the way of false expectations or over promising. That's bad, right? We need to be the antidote to hype is to focus on a concrete use case. You know, I'm going to predict which transaction is fraudulent in order to decide whether to authorize this credit card charge. That's like a very concrete use case. That's the nuts and bolts of what it means to secure financial transactions. I mean, that's a really big deal. Can we use science to improve it? Yes, we can, and it's done, right? There's many extremely amazing use cases that have been in place for decades now, including that for every credit card transaction, and that's done on the fly in real time. It's machine learning. AI is a brand that tends to anthropomorphize. It involves the word intelligence, which is eternally amorphous and is a word that really describes human. And when you try to ascribe that quality to a machine, you're in trouble. I love it for sci-fi and philosophy, but I think that we need to focus on value, very particular, tangible, concrete, and feasible use cases. So that's sort of my preference. Now, I don't mean to say that anytime you say AI, you're committing a sin. And in fact, because of that, I did use it in the title of my book. My book basically pivots quickly. I'm like, well, by AI, what I'm talking about is machine learning. Let's be concrete and specific. And then for the rest of the book, I call it machine learning. But the world knows machine learning as the term AI. Unfortunately, it's also how it often misunderstands machine learning.
Yes, and my apologies to folks who've heard me say this over and over again, but I often say that the best thing that happened to artificial intelligence was that it was called artificial intelligence, and the worst thing that happened to AI was that it was called artificial intelligence.
Exactly.
It
Yeah.
both drives an incredible interest and excitement around what it is that you're doing, but it also sets you up for those misperceptions because people automatically go to what they think the term means versus what it actually means. Um, and arguably, I think that's one of the things that you're trying to address here is, well, let's leverage the interest and excitement around it. Let's call it AI when we need to, because it is AI. The AI is arguably an umbrella term that is prime, and where the most interesting and exciting things that are happening right now are on the machine learning side of things. So it is absolutely an AI project, but I've also often said, we need to move to a post AI world in the sense of then we need to get very specific about what it is that we're talking about. And it sounds like that's exactly what you're advocating for is
Yeah.
get to what you're using it for sooner.
I mean, a rose by any other name, right? We call it a smartphone. And in general, that doesn't entail any overblown grandiosity. Unfortunately, I can't say the same thing about the way the term AI is used in general. So, yeah, it's an umbrella term, but unfortunately also has that problematic side to it. But and what you just said also kind of reminded me of what the industry seems to be doing with generative. Generative is extremely valuable. It's its own thing. First draft of writing and coding can potentially be really valuable depending on your work context and process. Um, but a lot, or if not most, opportunities for enterprise returns are in the predictive applications. So what I'm hearing from big consulting firms and such is and you look on their homepage and you look at all of their content they're putting out there, it's all generative. That's what's so hot right now. But they're very transparent they're very blunt behind closed doors, which is, look, we talk generative, and then once we're talking to the client, we pivot. Right?
Mm.
That's the leader. That's the story gets you in the door, and then oftentimes it turns out you're turning to predictive machine learning models, basically.
Yes, there's that minor detail that there's actually a back catalog of hundreds, thousands of use cases that there is a positive ROI on that we actually know how to go after. Why aren't we going after those? So there's an element of it whereby, yes, leverage the excitement around generative AI to then go after, build your capabilities, go after those traditional quote unquote predictive AI use cases. It doesn't mean you should probably ignore the generative AI side at all, because people are going to come knocking afterwards after a year and under. Yes, so you were successful. What did you do on the Gen AI side? And I think that there are certain use cases that are emerging as very powerful, like whether it be customer service automation or RPA on steroids, or the augmentation of individual roles, like if you are a software engineer, or soon to be if you're an analytics professional, certainly if you're on the marketing side and creating content. All of these roles are going to be leveraging generative AI, but it's not the magic box that will automatically solve all problems and can be used everywhere and anywhere. And arguably, that's on us for having come with that expectation to it.
Yeah. So, I mean, should we all take responsibility for that misleading narrative, or should we blame just a small, powerful few?
Oh, yeah, probably both. Would love your thoughts on how folks should use the book. So, if you are a data scientist, it sounds like very useful in terms of upping your knowledge, in terms of bridging that gap to the to business stakeholders. If you're on the business stakeholder side, sounds like it's useful for going in and upping your understanding of what these projects are going to look like with the information that's actually relevant to you. Is there an element of this which is, for the data science leaders and executives to go and say to make this, take this book and give it to your stakeholders so that they have so that they understand and don't come to you with completely overblown expectations, or the idea that, I don't have to do anything with this. This is someone else's problem.
Right. No, exactly. I mean, the books it's meant to bridge that gap. So, right. It's, I don't agree with Abraham Lincoln, right? You can't please all the people all the time. The book is meant for both sides, but what that means for the technical data science reader is they're going to be reading a book that's accessible. It's not their usual fare. So some of the chapters are going to be like, oh, I already know this. What I actually say up front in the book in a FAQ is, look, if you're a technical reader, totally read chapter 0, give the overview for why we need this practice and why everyone needs to ramp up, and what kind of particular literacy even the non-data scientists need. Then give the book a really good skim, but there's another couple chapters you need to read, even though you're a data scientist. We don't have coverage from a conceptual place of data prep, and preparing the data is the way you're framing the particular problem. That's where you're manifesting whatever the prediction goal, which is determined by the business goal, and has to be determined with business considerations and collaboratively with business stakeholders. The definition of the dependent variable. You need to get your head around this in a conceptual level that's just not common in the rhetoric or the training or the books around practical enterprise machine learning projects. And then chapter 3, on step 3, establishing the metrics, same thing. Look, you know what area under the curve is, but do you know what the problems are with it and what the alternatives are, and what we need to do with the business? How do we bridge the gap to business metrics? So that we're actually speaking a business language and providing that transparency to business stakeholders. So there's parts of the book that even really senior data scientists, in my opinion, many of them still need to read.
Well, you're reminding me of just how often people complain that data scientists are spending most of their time doing data engineering. And the sort of mistaken implication here is that, oh, well, that means that I should go and hire data engineers instead of data scientists. That's missing the point that, well, it's the data engineering that's done by the data scientist that is valuable, not the data engineering that's gone and done off in a vacuum. Unless you're doing the data engineering in alignment with what you're trying to accomplish, it doesn't really mean anything.
Yeah, and I talk about that. There's a lesson learned from some senior practitioners. I call it the data disconnect and how to overcome it, so that if you did have them in separate roles, data scientist and data engineer, there's a way in which they really have to collaborate. Data prep is often ad hoc, but you need to be planning from the get-go what deployment's going to look like, so the data engineers are setting up the right pipelines in accordance. You're not just sort of hacking a bunch of convenient data prep new features or what have you as a data scientist. So that's part of the end-to-end practice. I talked about that in the data prep chapter.
Again, starting with the end in mind, if not either working your way backwards from it, or in taking into account in the beginning and iterating on it throughout the life cycle, presumably.
Yeah. Yes, exactly.
I did want to take advantage, though, of the opportunity to ask you about humor, though. There's so few folks who have leveraged the power of humor when it comes to teaching generally, let alone teaching in the space of AI and machine learning. And you've been doing this for a lot longer than anyone else. I remember those songs from like 25 years ago, related to technology, that you created, which is a testament to just how powerful they are.
People don't dig data. Boring's the sentiment, crapped out by technology, electronic excrement. But my theory is the data is experience, serious, and deep inside the data is the key. See, predictive analytics learns from the data you supply and predicts if you will click, buy, lie, or die. It ain't astrological, it's math, it's methodological. So better pay attention because my flow is pedagogical.
Your data.
How do you think we should be leveraging humor more?
Well, so as you opened this episode with, I've proven that I'm willing to do anything, despite my own appearances, to help educate, ramp up, and achieve that data literacy on predictive analytics, machine learning, whatever you want to call it, with that Predict This wrap. I have another educational wrap hidden within my online course of 141 videos. The middle one is an overview. But yeah, when I was a professor at Columbia, I started writing these educational computer science songs, including a machine learning wrap at the time, but also just about pointers. That's a programming thing, a pointers wrap, an AI Rhapsody, and a debugging, the rock ballad about the onks debugging your computer program. These are all available. If you Google computer science songs or educational songs, you'll find them, or especially if you put my name in there. So I have recordings, live recordings from the classroom from whatever it was 25 years ago. And at the time, as an academic, I published a research article in a computer science education conference and its proceedings. And I went to Krakow, Poland and presented on it and sang some of the songs for the other educators in the audience. But my message was, look, if you don't have to write a song, but you got to do something to bridge that gap, because the expert is often sort of seeing the trees for the forest. But when you use humor, you're bridging that gap and you're saying, hey, look, there's a broader perspective on this. There's also, subtext. Are we just a bunch of nerds? But there's also sort of like, what does it mean to take the concepts and put them in a humorous light, which is a way to put perspective on how, wait, prediction really is valuable. It's a kind of a game changer. And let's not beat around the bush. This is what it means to use science to improve business.
Well, it sounds like it's a forcing function to make sure that you are actually conveying it in a way that folks will understand, or forces you to sort of think about it from an outside-in point of view. Now, obviously, it's easier than ever before to go in and leverage a generative model for this. I myself have had great success, depending on your definition of success, going in and taking my talks and asking ChatGPT to go in and transform them into a song in the style of Tom Lehrer or a Gilbert and Sullivan song. But I'm suspecting that's not really hitting the mark. That's not really the purpose around that. Or is there a way in which we should actually leverage some of these tools and go in and create more humorous content, get that out there, and get folks engaging with this in a more accessible way?
Like for me, the accomplishment is make it cute, funny, have some clever stuff and make it rhyme, but also cover the main conceptual points. So I have sort of an educational agenda when I write these. And I don't know how well language models would do, but I guess if you spelled it all out, it's certainly worth trying.
Well, you talk about the ML paradox in the book, and just how the need for human involvement increases with your leveraging of machine learning, and it sounds like that applies here as well. It's like, well, if you're hoping for this to come up with something that is both entertaining and educational easily, you're probably missing the point. It is a tool to augment your inner entertainer comedian more than that this will be something that can do it for you. A pleasure having you on the podcast. If folks want to meet you in person, when and where can they do that?
Oh, well, the conference that I've been running since 2009, Machine Learning Week, is going to be in Phoenix the first week of June at machinelearningweek.com. And we've got a co-located new conference called Generative AI World. So you can find out at machinelearningworld.com. And the event also takes place in Europe. It's in Berlin in October.
And please check out Eric's new book. Again, it is The AI Playbook, Mastering the Rare Art of Machine Learning Deployment. And if you haven't seen that music video, we will have links to that, the book, and conference in the description of the podcast. Thank you so much.
Thanks, Joe.
You've been listening to Data Science Leaders from Domino Data Lab. If you found our discussion insightful, be sure to subscribe to never miss an episode. Your support helps us deliver cutting-edge content and keep the data science community informed and inspired. We appreciate every review. Until next time.